initializer list. What is this? See, how in a class student, I may have so many private variables and public variables. I may have private and public variables. Okay, and we already know that these private variables, private data members, not variables, we have to call it as data members, right? Private data members cannot be initialized outside. Okay, if I create in main, if I create an object student s1, okay, if the variables here are int a comma b, for example, right? If the variables here are int a comma b, so I cannot write s1 dot a equal to 10, s2 dot s1 dot b equal to 20. I cannot do this because they are private variables. For that, what solution I gave? We studied constructors. We said that using constructor you can initialize those private variables. We have studied in the previous session that you can create a constructor with the class name student. So you can write there student of, you can give two variables, int x comma int y, and here you can write a equal to x and b equal to y. Oh, sorry, x equal to a, yeah, correct, a equal to x. And so while creating an object, what you can do? You can create an object s1 with some values. You will create student s1 of 10 comma 20. Like this, you will be creating an object, right? So we studied that private data members cannot be initialized outside. So the alternative was using constructor, using parameterized constructor or default, depending on the context. So we can define a constructor like this, and you can pass the values 10 and 20, so that these private data members of the class are assigned some values, right? But there can be some situations, where using a constructor, we cannot initialize values. There can be some type of variables, okay? There can be some type of variables like static, okay? I think we studied static data members. We have studied this concept already, static data members. So there are some kind of situations, not only this, there are so many situations where a constructor cannot help us in assigning values to the private variables. Okay, we cannot do that using constructors also. In those situations, we have to use initializer list concept. We have to use this method, okay, initializer list method, to assign values to the private data members of the class. Why always I am talking about private member? Because public can be directly accessed using the object. If there is a public variable outside class, it means inside main, I can create an object s2 and I can write s2 of a equal to 10 if there is a variable a here, for example. I can do that. Whereas private, it's challenging. For that, one way was constructor, but there can be some situations where constructor also can fail to assign value to the private members. For that, we follow the concept of initializer list. This is another way of assigning values to the private data members. Unlike constructor, it follows some different structure and syntax to assign values to a private data members of the class. Okay, so this is the main use or the purpose of initializer list. How it does, let us see. Let us see some points about it. Initializer list is used in initializing the data members of a class. Okay, the list of members to be initialized is indicated with constructor as a comma separated list. Okay, see the important point. There are some situations where initializing a data member of a class is not possible with constructor. In that situation, we will be using the approach of initializer list. Okay, but the important point here is that, see, even if it is possible, okay, I am saying that if you have a constructor, you can assign the private data members or data members of the class. We can do that. Okay, so you can use initializer list. We are saying that initializer list can be used wherever we cannot initialize the values using constructor. But in a given situation where I can initialize values using constructor, there also I can use this initializer list. So it's kind of an alternative only for constructor. Either you can use constructor or initializer list. If constructor is allowed, you can use it, do it accordingly. Okay, even if constructor is allowed, still you can use initializer list. But specially wherever their constructor is not allowed, there you have to use this. So some advanced programming, if you see in C++, they will be not using any constructor to assign values. By default, they will be using initializer list. Even that is possible using constructor, still they will be using this concept. Okay, to avoid confusion, because I do not know in what situations constructor will work and what situation constructor will not work. So it is better always use the initializer list to assigning the values to the private or the data members of a class. Okay, it's a common pattern. You can use this. I would say this is you can replace constructor with this approach. Again, it is not replacing. It is kind of adding a few more syntaxes to the constructor class. Let's see an example. Let's just again a dummy example just to show you how constructor this initializer list works. See, generally, how do you write constructor? With the class name. What is class name? Point. Suppose see here, point, you see the main function, point t1 10, 15. So I am passing parameters. So I can easily create, right? I can create here parameterized constructor. I can give here int a, comma int b. This is a parameterized constructor. I am defining it inside the class. I can write what is the variable here, x and y. I can write x equal to a and y equal to b. I can do this. I can do this using parameterized constructor. This is possible. Okay, but to understand how initializer list is also used for assigning values, this is an example. So how to write it? See here. See the example here. We are writing point. And again we will ignore. I'll write here. See, int I, comma int j. I gave two variables. Put colon, and what is the private variable name? X. X in brackets this I, comma y in bracket this j. Okay, open flower bracket, close flower bracket. Okay, I will rewrite this. I will show you different ways. See, if I have a class, student, I have a class student. In this, there are two private variables, int a, comma b, and there are some statements. I can use to initialize the values to this a and b. I can use parameterized constructor. How to use? You have to how to define a constructor? Use the class name. Okay, class name student of, write some variables there, int x, comma int y, and in flower brackets you can write this private variable a is equal to this x which has come from the object. Why? In main, in main, what will be doing there? In int main, we'll be writing something like this. We'll be writing the class student object s1 of 10, 20. So when you write like this, once you create an object, immediately the parameterized constructor will be executed. Why? I am passing two values. So that is copied into a and y value is copied into b. This is my one approach. We already know this. Okay, you can, once you create an object s1, so this 10 will be copied into this x, this 20 will be copied into y, and those values are copied into a and b. Using the help of parameterized constructor, I am able to assign the values. Now I am looking for alternative ways of initializing the private variables. One, how to do this? This is valid. This is perfectly valid what we wrote here. This will initialize the values. But there is another way of doing it. That is using initializer list. What is the syntax for that? Same thing. Same class student, private a and b. But instead of writing student like this, you will write like this. Student of some int x, comma int y. Okay, let me write it little here. It is a lengthy statement, so I'll write it here. Student of, okay, some int x, comma int y, close the brackets, put colon. What is the actual private variable name? A. You write a of x like this, comma. What is the other private variable? B of y. Okay, after writing like this, student, this is normal, no? This is your parameterized constructor. We have been writing this. See, same thing I wrote here. This is normal. We already wrote this parameterized constructor here. Student int x comma y. This is my parameterized constructor. Same thing I wrote it here. Then I kept colon. Then I kept colon. What is this a? The private variable name. What is this x? The value which is coming from the object, comma b of y, comma, so on. If there are n number of variables, you can keep on putting comma, comma. After this, see, a of x comma b of y, a of x comma b of y, just write open flower bracket and close flower bracket. That's it. What it will do? This is another way. This is another way of initializing. So instead of writing these 4 lines, see, instead of writing this line, okay, student int x comma int y, open flower bracket, a equal to x, b equal to y. Instead of writing this, we can do this way also. How to write? Student int x comma int y colon. This a is nothing but the actual private variable of this x is the value temporary variable. No, this is temporary only. No, that I am writing a of x comma b of y, and then write open flower bracket and close flower bracket. Nothing else in that. Indirectly it means this block a equal to x, b equal to y, I am shifting it to this location using colon. Okay, so this is the syntax of initializing default values to initializing values to the private data members of the class. Either you can use parameterized constructor or you can use the initializer list format. So in this example, if you see I have a class point. I am having private int x int y, 2 variables, right? So I am creating point t1, object t1 with 10 and 15, object t1 with 10 and 15. So generally what we should have in public, we should have a parameterized constructor. Okay, we should have a parameterized constructor, but instead of using parameterized constructor, I am using the concept of initializer list. How I am doing that? You can write it like this: point int x comma int y colon x of I comma y of j. Sorry, here it should be I and j. I and j are temporary values, I and j, where x and y are the actual private values. You can simply write like this: open flower bracket and close flower bracket. This will do the same job like our parameterized constructor is doing. It will do the same job like our parameterized constructor is doing. Okay, this is just to demonstrate you how to use initializer list concept instead of constructor concept, whether it is default or parameterized, whatever, right? But I said that there are situations where initializing a data member of a class is not possible with constructor, this point. So what are those situations where we cannot do it using constructor? Okay, let's try to see what are those situations where we cannot do it using constructors, right? Let's explore. So first one, right? Whenever for initializing non-static constant data members, okay, first use of this initializer list is initializing non-static constant data member. Okay, let's go back, recall the concept of static data member. Static data member. How do you initialize static data member of a class? How do you generally initialize? You can outside the class, you can write the class name, use scope resolution operator, write the variable name and assign some value. This is the way we initialize values to the static data members, right? Now, if there is a non-static constant data member inside the class, see, const entity. If there is a non-static constant data member, that data member should be initialized using initializer list only. That cannot be done using constructor. You cannot initialize value to that variable using constructor. Okay, so how we are doing it? See, there is a variable entity which is private. By default it is private. So I wrote the class name and some variable x colon, what is the variable name here? T of x. That's it. This is the syntax. This is your parameterized constructor colon the actual private variable brackets the temporary private variable open and close flower brackets. That's it. Okay. So if there is a constant data member, if there is a static data member, what we have to do? You have no other option. You have to go ahead and define outside the class only. Okay. But if there is a non-static constant data member, that can be initialized using the initializer list. So this part is the parameterized constructor part only. I am putting colon here, colon the actual temporary actual private variable, in brackets the temporary variable, open flower bracket, close flower bracket. Okay, so this is an example of initializer list. See what happens here. Int main, I'm creating an object test t1 of 10. So this default parameterized constructor, which is defined as initializer list, will get executed. So it means what will happen with this? T will contain 10. T will contain 10 with this statement. Then I am writing t1 dot get t. T1 dot get t means this is a public function. So I am calling it. It will return t. What is t value now? 10. So I will get 10 as the answer. Just a simple demonstration. But the important point here is that if there is a constant data member, we have to use initializer list only. We cannot do that using constructor. Next one. To initialize reference members. Okay, reference members means like this, int ampersand t. Okay, you can use constructor concept only if the variables are simple normal variables. If they are pointer variables, if they are reference variables, you have to follow initializer list method only. Constructor cannot help us in initializing the private reference members. See, this is a private variable, int ampersand t. It's a private variable. How do you initialize this? Again, I will use the initializer list concept. You can write class name, you can write the parameter ampersand x. Why ampersand x? Because it's a reference variable. Colon, the actual variable is t and the dummy variable is x. Open flower bracket. That's it. Sorry. So this is the statement. This will initialize. See here, this will initialize the reference variable. This will initialize the reference variable by default. So this is again kind of a parameterized constructor only, but instead of doing it using constructor, we are doing it using initializer list concept. See here in this program, x is 20. I am writing t1 of x. That is 20 is being passed here. That is copied into t. I am t1 dot t means I get 20 here normally, but we are doing that using reference. Instead of doing directly with a variable, we are doing using reference. Then I am assigning x is 30. Again t1 dot get, I get 30 here. Normal execution. So if there are reference members in a class, you cannot assign values to them using constructors. We definitely have to use initializer list. Okay. I hope by this time you understood the syntax. It is very simple. You have to write class name, in bracket the arguments, then colon symbol, the actual private variable, in bracket the dummy private variable name. Like this you can put comma separated values and then open flower bracket and close flower bracket. This is the syntax of initializer list. Okay, right. Let's see the third use of this initializer list, for initializing of member objects that do not have a default constructor. Okay, suppose there is no default constructor for a class, then you can do that. How? Let's see an example. Again, we need the concept of inheritance here. Inheritance is our next concept. In the next unit, we are going to study inheritance. But this point number 3, the usage of initializer list is mostly related with inheritance concept. But anyhow, we will try to understand what this point is telling to us. For initializing the member objects that do not have a default constructor, right? See an example. I have a class A and a private variable I. Then I have a function A. This is a parameterized constructor. A int arg I equal to arg, right? So this is a parameterized constructor. Normally fine. Then I have another class B. That class B has an object of class A. Class B is having the object of class A. See, A of A. Class A exists. I am creating an object A for that. Right. Then public b int x colon a of x. This is this is the initializer list. What I am trying to do, what I am trying to initialize, I am trying to initialize the object A of class A, the object A of class A in class B. That's why I wrote here, no? See, we wrote here B of int x, that is B means class name, int x means the variable, this is a parameterized constructor, colon the actual private variable, that is A. What is the actual private variable here? A. Meaning of A is an object that I am copying into X, right? So this is an example to demonstrate. Again, you need to understand inheritance concept to understand this much better, but we will talk about this. We will, when we study inheritance, we will again recall this concept there. The initializer list way approach of assigning values to a object in the derived class or some other class. We will see that in the inheritance concept. Next one, the fourth one, and the again which is based on the inheritance concept again, right? For initialization of base class members. Base class members means there is parent class and base class or parent class is same, child class also exists, right? So see, class A is there, I have a private variable I have written here parameterized constructor. Class B is there, which is inherited from A. Class B is inherited from A, right? So this A, it means I value I am passing it from the class B. I value I am passing it from class B. So this usage number 3 and 4 we will be understanding much better when we study the inheritance concept. Okay, so if you see here, what are the different ways of initializing? What is initializer list here? It's a one way of assigning values, default values to the private data members of the class. There can be some situations where constructor cannot be used. You can even use this initializer list wherever constructor is applicable. Still you can do that, no problem. Either use constructor or use initializer list. Okay, so for constant data members, for reference members, you have to use this initializer list. Okay, so member initializer list. One more point we will just quickly see that. So there is a class my class, and there is a pointer variable. There is a pointer variable. That's what if the variable is normal variable, you can use constructor concept there. But if it's a reference variable, pointer variable, then you have to go it for initializer list. Meaning that constructor can be used only for normal variables. Okay, so syntax is very simple. My class, that is class name, int value, the data belongs to the data is the actual private variable of int value You can write it like this. So this will come, same will come here. Okay, new is again a keyword in C++. Again we have to study STL libraries for that. New is a keyword in C++. This will allocate memory for this variable value. It will allocate memory for this variable value, right? So this is again a syntax of member initializer list. When you have a pointer variable, you can assign that using this way, right? What is the meaning? What does this statement mean? Okay, the statement my class, this is a member initializer list that initializes the data member. What is the data member? It's a private variable. To initialize that, I am using this line. In this, what is this int value means? What does this indicates? It indicates a local variable. This is the constructor parameter passed by the value when an object is created. It means for this my class, I will be creating m1 object with 10, right? So this 10 is nothing but this value. Okay, what is data new int value? What does this indicate? What is the meaning of this? It is a member initializer list to initialize data which is a pointer to int, See, pointer to int. What happens here? New int value dynamically allocates memory for an integer, initializes it with the value provided by the value parameter. This 10, see, to store 10 in this data, we are writing this statement. Okay, so when you write new, dynamically memory allocation is happening for this variable value. Okay, right? So in this constructor, you are creating an integer on the heap using new. New is a keyword which is used to allocate memory. See, assigning address of the delegate memory to the pointer data, right? So if you have a reference variable, if you have a pointer variable, right, if you have a constant variable, we definitely have to use initializer list. We cannot do that using the initializer list, right? So the last important concept in this initializer list is move assignment operator. Okay, move assignment operator. Move assignment operator. What is this operator? Move assignment operator in C++ allows an object to take over the resources of another object that is going to be destroyed. Okay, let me talk about copy constructor here. Okay, any free space? Yes, I will talk about copy constructor first. There is a class student. So for that student class, I am creating object 1 O1 with values some 10 and 20. So what is happening? As soon as you create an object, the default constructor will be executed, that is parameters constructor will be executed and memory will be allocated. So it will object 1 dot A will contain 10, object 1 dot B will contain 20. This is what happens when we write this statement. Okay, memory 4 bytes of memory is allocated. Assume integer takes 4 bytes, so 4 bytes of memory is allocated for these two variables. It means in your RAM, in the whole RAM, there is something called O1.A. It will have the value 10. Let that address be some 100 for simple understanding. And there is another block O1.B with value 20, and let this address be 6004. Some random address I gave here, right? I am talking about copy constructor. I create an object O1 with 10 and 20. This is what happens when you do this. Now I am creating another object O2 and I am writing here O1. I am creating another object O2 and writing here O1, right? So when I write O1 here, what is this? What is the meaning of this? This is nothing but the copy constructor. What it is doing in your memory, another block O2.A is created with the same value 10, and another box here with O2.B with same value 20, but a different address. Let this be 700, let this be some 496. Okay, when you write the second statement, student object 2 of object 1, this is the implementation of copy constructor. What is happening? The values 10 and 20 of object 1 are copied into values 10 and A and B of object 2. So if you see here, how many values are there? Actually 2 values only we are assigning, but how many variables are created? 1, 2, 3, 4 variables are created, right? So if I now, after writing this statement, if I delete the object O1, if I delete object O1, will the values of object O2 arise? No. If I even make this object A1.0 and if I make these two values 0, will the object 2 values change? No. Why? We have already copied it. After copying, after writing this first line, second line, in third line, object O1 dot A I am putting 0, object O1 dot B I am putting 0. So this object O2 values are not changing, they are having 10 and 20. So what is happening in copy constructor? In copy constructor, we are actually creating two more variables A and B and copying the values of object 1 A and B into object 2 A and B, right? So the values are different, memory allocations are different. In this copy constructor concept, we are having like this: O1.A, O1.B can contain 10, 10, 10 and 20, right? When I use the copy constructor, two more variables are created with some address and some values are placed in that. 10 and 20 are copied into that. Now there are like two memory addresses, two separate memory addresses and separate values. You can perform operations separately. On object O1 you do something that will not reflect in object 2. Object 2 you make some changes that will not reflect in object 1. Why? Once we have copied, it's like x equal to 10 is there, you are writing y equal to x. No, same thing I am doing it here in copy constructor, right? So with this background information, let's go and understand what is move assignment operator, right? This operator, this move assignment operator, allows an object to take over the resources of another object that is going to be destroyed. Meaning, with the same example of copy constructor, if there is object, okay, I have student O1 with 10 and 20. I have another object student O2. For now, I am not writing the syntax, just explaining you. There is another object O2. If I use copy constructor, totally this is taking 8 bytes. This will also take 8 bytes. Okay. Whereas if you use move assignment operator in your RAM, you will not create two more variables. You will not create two more variables. What will happen in your RAM? See, like this. Okay. So we had O1.A as 10, O1.B somewhere here as 20. When you use move assignment operator, right, allows an object to take over the resources of another object. I will have another object O2. This O2 will refer to the same location O2 like this. So O2.A, O2.B. We are not creating extra memory space. We are referring to the same memory block. And we are deleting, we are erasing this object O1 and O2. This is what will happen if you use move assignment operator, and this is the foundational concept for understanding the move constructor. Okay, what move assignment is doing? Copy constructor is making a duplicate copy by allocating more space, whereas move assignment will be referring to the same memory location. It will not create any additional space, right? So this is about move assignment operator. How we generally do that? The syntax for move assignment operator. Okay, it is little complex to understand. We will just see when we see the implementation, it becomes easy. So I have tried the class name, I have tried the ampersand, and the operator is equal to my class double ampersand another variable and no except. Okay, little complex to understand. In the due course you will understand it as time goes forward. Once we solve more examples and see more programs, you will get familiar with this move assignment operator. You have tried the class name, ampersand symbol, and the operator. We will see the example. Equal to my class double ampersand another variable here. Okay, what is the meaning of this? If you see, right, see, take resources from other and make them our own, right? So there exists object O1, it has some resources, take them and make it our own, write it in terms of O2, delete O1, remove the O1's references, O1 completely you erase it. It should look like those are the values of O2 object. Okay, and since we are pointing to the same memory location, we have to return the memory address. That's why we are using this pointer. We are using star of this. We use this pointer here. Let's see the move assignment operator functions. This operator function uses a special double ampersand reference qualifier. We use a double ampersand here, right? It represents the R value references. Okay, when we see the program, you understand it better. Usually it returns a reference to the object. See, object O1 had some values, no, 10 and 20. What I am trying to do, I am creating object O2 and referring to the location of O1. I am referring to the location of O1. After that, I am erasing this O1. After referring, I am erasing O1, right? Since I have to return the current object, whatever is the memory address of this current object, that I have to return. For that, we are using this pointer. Okay, so this is about move assignment operator. You will understand this much better in the concept of move constructor. But this is the little idea of assignment. See here, I am writing equal to move assignment operator. So there exists O1 and O2, right? It is kind of, I will simplify this in simple terms. It is kind of writing my class ampersand O2 equal to my class double ampersand O1. Means copy the contents of O1 into O2 and delete this O1. That is the syntax of this. So these are the concepts under the concept of initializer list. I hope we understood little about this initializer list. So in the next session, we will try to understand the move constructor and we will go for the implementation.